Hi everyone, here are your notes for section 4.23. I guess it's probably more from 4.2 since we're just doing 2x2 linear systems. But if you guys remember after break, before our 2-week break, if you want to call it that, we took a quiz on solving linear systems with 2 variables and then linear systems with 3 variables, and we didn't do any of the word problems work. So we need to get through that today. So we're going to go through some techniques that we can use when creating linear equations. So can we take a word problem and set it up so that it turns into a linear equation? So here we go. So for each of the problems, we're going to define the variables in words of let x equal this, y equals that, and then we're going to write the system of equations and then use substitution or elimination to solve the work and then state your solution in appropriate units. So here we go for our first one. Again, pause this as necessary because I know these are word problems and they probably take some time for you to solve. But we had last season 2 running backs on the Steelers football team rushed for a combined total of 1,550 yards. One rushed 4 times as many yards as the other. How many yards were rushed by each player? So if we let X represent player 1, and then Y represent player 2, so we have 2 different players. So it says here that combined total, so that means X plus Y is going to equal 1,550. One rushed 4 times as many as the other. Okay, so let's have this guy be the star player. So X is going to be the star player. So he rushed 4 times as many yards as the other player. So the other player, X, is 4 times the other player. So 4 times Y. And then to save ourselves some time, I'm assuming that you would then be able to substitute that you guys can solve them. Maybe the more difficult ones we can go through. Okay, so now it says the setup determines the method with which we will choose to solve the system. Since Y, the variable, was isolated, though I had X isolated, it was substitution that would have been the easiest, although it does not matter which method we choose. The answers will end up being the same. So this is where we get a little bit more challenge. The mixture problems. John wants to make 100 milliliters of a 5% alcohol solution, mixing a quantity of 2% alcohol solution with a 7% alcohol solution. What are the quantities of each of the 2 solutions? Okay, so I'm going to let X represent our number of milliliters of a 2%. And then Y is going to represent our milliliters of the 7%. So when I combine those together, I want to end up with a 5% solution, right? So I want to make 100 total milliliters. So that's our easy one. So X milliliters plus Y milliliters should equal 100 total milliliters. Now we've got to do the percent equation. Well, we said that X represented our 2% mixture. So that would be 0.02 as a decimal. Y represented our 7%, so 0.07Y. So now I got to figure out 100. So 2 minus 2, 6. And okay, next one. Dennis mowed his next door neighbor's lawn for a handful of dimes and nickels, 80 coins in all. Upon completing the job, he counted out the coins and it came to $6.60. How much did he earn of each coin? So X is going to represent our number of dimes. So number of dimes. Y is going to represent our number of nickels. All right, we have 80 coins in all, so there's our first equation. That's the easy one. X plus Y equals 80. Okay, so now we got to get the money line. So we have $6.60. Dimes is 10 cents, so 0.1x. Nickels are 5 cents, and that needs to end up being $6.60. Okay, so there will be our equation. Hopefully you would be able to solve that. If we wanted to get rid of the decimal, moving this over 2 would get me 10x plus 5y equals 660. Bringing this down would get me x plus y equals 80. And then you could either eliminate the x or the y by multiplying by -10 or -5. Okay, so I'm assuming we can do the solving part. It's the setup that's going to be the challenging part of these problems. All right, geometry. Two angles are supplementary. Ooh, does anybody remember what supplementary means? Supplementary means adds up to 180. So adds to 180. Okay, so x, larger angle is 48 degrees more. So let's let x be the larger angle and y be the smaller angle. So we know that together they should add up to 180 degrees because of the word supplementary, that's what that means. My larger angle is 40 degrees more than 10 times the smaller, right? So there's our two equations, and then we can solve using substitution. All right, D, our interest problems. Sally has $1,800 in her two savings accounts. Her total interest for the year was $93 from one account earning 6% interest and another earning 3% interest. How much does she have in each account? So X represents our amount. So again, it makes it so much easier if you actually identify your variables so you can think about what you're doing. So this is our amount in, let's say, our 6%, and Y can be our amount, in the 3%. In 3%. Doesn't like my finger anymore. Okay, so in her two counts, she has $1,800. So again, there's the first equation. That's going to be the easy one. X plus Y equals 1,800. Now let's do the interest. So her total interest, we're told, is $93. Remember, your simple interest is I equals PRT. So rate times time. Well, here it's just 1 year, so time doesn't really matter. So our principal amount times the rate, or rate times the principal. So X represents our amount, or our principal, in the 6% account. So 0.06 times X would be our interest that we gain in that account. And then for the Y, it'd be 0.03Y, so my interest times my principal in that account. Okay, so if I wanted to move decimals again, move 2, don't forget to move 2 here, which is going to add 2 zeros. So now you have 6x plus 3y equals 9,300. Oops, too many zeros. And then x plus y equals 1,800 would be our new equation. Or just deal with the decimals if you want to deal with the decimals. I do have students who do that. So then you could solve this for x and y by either multiplying by a -6 or a -3. Make sure your final answer has both an x and a y in it. All right, so now we're going to get into uniform motion problems. So there's all this stuff here saying about make sure you check your answers, make sure your answers make sense. If your answers don't make sense, then you probably did something wrong with your solving part or your equation setting up. Okay, so use logic and make sure everything seems like it's making the right sense. So here we have the idea behind distance problems, sometimes called uniform motion problems, is to organize the given data. So we have distance is equal to rate times time. And this is where those tables, if you guys remember from Algebra 2, come into play. So we have an executive traveled 1,930 miles by car and plane. He drove to the airport at an average speed of 60 miles per hour in a plane that averaged 350 miles per hour. The total trip took 8 hours. How long did it take to get to the airport? So if you set up D equals R times T. Okay, so then we're going to have X being our, what are we looking for? How long did it take to get to the airport? So length in car, I guess we should say time. Time in car, time, right, in, because how long, time in plane. Okay, so what do we know? He traveled a total distance of 1,930. So my bottom of my column for distance is going to be 1,930. He drove to the airport at an average speed of 60 miles per hour. Okay, so let's make this car and this plane, right? So we did 60 miles per hour in the car, so that's my rate here. We did 350 by plane, so I'm going to put plane there. And the total trip took 8 hours, so that's down here. How long did it take to get to the airport? All right, so our distance, actually, I guess maybe we do want this to be distance, right? Let me think here. Yeah, so I don't think we've got too many blanks. So we'll make this be distance and distance. Make those be our x's. I can't write. Doesn't like my handwriting, my finger today. Okay, so we'll make this be x, this be y. So now think about your distance is equal to rate times time, which if I solve that for time, time is equal to distance over my rate. So my time here, distance over rate, so x over 60, and this would be y over 350. So now here are your two equations. There's equation 1, there's equation 2, right? So distance is x plus y equals 1,930, and my total time was x over 60 plus y over 350 is equal to 8. Okay, so now how do we solve that? Well, one, we could get rid of our decimals, or not our decimals, our fraction. And let's see, if I multiply everything in line 2 by the 21,000, then I get 350x plus 60y equals times 8 is 168,000, right? Now I can bring this down, so x plus y is equal to 1,930. Multiply everything by, let's say, negative 350. Sorry, I'm getting really sloppy here. So we got negative 350x minus 350y is equal to 1,930 times negative 350 is negative 675,500. Combining that with the first line, so 60 minus 350 gets me negative 290y, 168,000 minus 675,500. Oops, I'm not typing in the right numbers. Minus 5,500. Let's be negative 507,500. Dividing that, gives me y is 1,750 miles. Would be how much we're in the plane, right? Subtract that from 1930 means we have 180 miles in the car. In plane. Whew. Sorry about that chicken scratch, guys. Hopefully you followed along on that. All right, and then the last one we have our boat. It says a boat traveled 24 miles downstream in 2 hours. Its return trip took twice as long. So again, we have distance, rate, time. We're going to have upstream, downstream. X represents the speed of the boat. And y is going to represent the speed of the current, because you got the current pushing against you. So these problems, you're always going to have unknown speed, unknown current. All right, so it says the boat traveled 24 miles downstream. So downstream, there's my 24. Took 2 hours, so total 2 hours. The return trip took twice as long, so that means it was 4 hours, but the distance still stayed the same, right? Because we're still going down and up 24. So now this is where we got to get our rate. So if you're going upstream, you're going to be going slower. So you have your speed of your boat, which you're subtracting the current from that. And downstream, you have your speed of your boat, and you're adding the current. So again, if we do that same ratio, or actually you can just do your equations right here, right? So distance is equal to rate times time, and then distance is equal to rate times time. We could either distribute our 4 and our 2, but I'm going to divide it out to make smaller numbers. So now we get 6 equals x minus y. 12 equals x plus y. Notice your y's cancel right away, so 18 equals 2x. X equals 9, so that means that the speed of my boat is 9 miles per hour. Plugging 9 back in would get us 3 miles per hour would be our current speed. Okay, there it is. See if you can do some word problems, guys.